So today we have a digital input-output system for selecting our presets. Without something like this or the bit selectors you've seen in other videos or things like that, you have to go in and assign that task to the virtual station. If we're not using a barcode scan or an input-output system to choose our programs, then we do not have a way without physically going to the controller to change them to make sure that we're going about that process. In this case, we use something like a dial selector. So if you come over here, we would see preset 1, 2, and 3, and that's how we set it to the tool. So how does that work? So first, the controller doesn't get power itself to the input-output dock here. So we have to run 24 volts from the controller itself, where we are getting power, to the 24 volt input on the controller. So now this is getting power. So from there, we now need to wire the rest of it, where from here, we have to run from 0 volts to our COM port, and then what you see below it are the digital input 1, digital input 2, digital input 3, and digital input 4. So from there, what we have in here is we have our 24 volt looped in with each of our inputs so that they're getting power, and that is how we're going to go in and configure it from the controller. So first, just like always, we have to have our presets already created. So let's say, for example, here we have our 3 presets created to 2 newton meters, 4 newton meters, and 3 newton meters. So that would be a case in which we had a part and we need to do several different tightenings, and we don't want them to have to walk over to the controller and pick a new preset every time they want to do that. We want them to know what those presets are and be able to select on this dial which one they want. So once we have those presets created, we need to come over here to sources, and we're going to create a source tightening process. So from there, we would name it. And this is where we start to introduce for the first time what each of those numbers are gonna mean. So if you come back over here to our dial, you see we have 0, 1, 2, and 3. So we do have to have 0 because 0 is always going to lock out the system. So you can know for airproofing processes and making sure an operator is not using it when it's shut down, that it should be set to 0, and in that case, it's locked out. But then from there is when we start to use those numbers as identifiers to show what they will mean. So for preset 1, we want that to be the first dial number here. So we have that identifier number set to 1. If we would want to switch to preset 2, then we need to give that and assign it to that preset and then give it an identifier number. So as you see it set here, we would have it set up to match these. So right now it is now set to pick up those presets as we go through, and we're gonna apply that change. So we have now created a source tightening process, but we also need to check to make the configuration. Because this is an IO system, we're gonna go to internal IO, and that is where our configuration is gonna be set up. Different input outputs and different devices will have different options here of what you want to do, but because we are now selecting a preset, we're going to start with select input 0, just like I said earlier, because we are using binary. So that has already been set, so I'm not going to change it, but that's what you would select it to. And you would do that incrementally going up depending on how many inputs you want to be put into the controller. The next step in this process is setting up this configurator to have select input 0, 1, and 2. And then if we needed another one, we would add it here. So we are now gonna go back out of here. And we've now created all the pieces, but we need to assign that to the controller to tell it that that's what it's going to do. So we have our virtual station here. Always make sure we have a license for it. Always make sure there's a tool assigned. But then we need to come out here and give it a task. So a lot of the times in the past, if we're just using tightening programs or even a batch, then that's what we're going in and selecting. But that's not what we're gonna do here. We're gonna go into sources, and we're gonna select that source tightening that explain the identifier numbers here. So the last thing is making sure that we've actually received signal and are communicating through these wires. So that's where we would come down here and choose an accessory. So if I hadn't set this up already, the first thing you need to do is click this puzzle piece and this puzzle piece. And if they connect correctly, then you'll get them to show connected down here below. What we can also do from that tab is get a little bit of a breakdown in terms of what we are seeing and diagnose any possible issues with the signal. So as I showed you before, we had it wired and we have digital input 0 here, which is 1, and we would want that to be active. If we went to the next, we would want to see select input 1 be active. So this is what I meant by diagnostics. We are at least double checking that we are getting the signal that we had hoped. That 0, we've assigned that to be locked out. That comes default on the controllers. We ran that through the diagnostics, but if we switch to 1, that is going to make sure that we have signal to input 1, and our preset 1 is then up here, which if we did a tightening with our tool, and the bit selector, socket selector, they all work in a very similar fashion.
So you can see the switches on 0, none of the bits are active. If I put it on channel 1, it shows active. Select input bit 0 active. And what channel 1 is showing on the digital inputs, input 4 has 0 volts, input 3 has 3 volts, input 2 has 0 volts, and input 1 has 24 volts. And the way we check that is we put the meter on DC, and on one side of the common, we put one side of the meter, and we check digital 1, and there, you can see on the meter we have 24 volts. And that's how the binary works.